Hi there, it's Ian McTavish, and I am from Huntsville High School, and this is the TLDSB math lesson on coding for basketball drills. So the goal of this lesson is to program a robot to complete basketball drills. And with basketball drills, the idea is that you run forward to a line, you run back, then you run to the next line, run back. And so we're going to program a robot to do that. First thing we're going to do is just generate output. This is our Hoya Robotics robot, and one of the first tests we do is just to make sure that the motors run. So that's the first goal, is being able to drive the robot. And we're going to start off by going to vr.vex.com. And I've already got that set up here. Excuse me while I switch screens. So this is, when you go to vr.vex.com, this is the screen that pops up. I highly recommend that you watch this tutorial video. And if you've already closed it, you can access it. There's tutorials, there's all kinds of resources in here, so you can easily bring that back up. So we're just going to close that up. And the first thing is that we have our getting started, when started block. And so over on the left, we have the different blocks, and we're going to have this block drive forward for 200 millimeters, and we're just going to put that in place. And we're going to click Start. Now, when we click Start, it opens up our playground. And so our playground is where we can actually see the robot, and we can see it moving around. So the playground is loaded, and there's our robot, and it's moved forward 200 millimeters, and that's all our program does. So we can just stop that. We can restart it. And there we go. The other thing is that we can change our camera angle so that we can see the robot from different perspectives. And we can hide all the extra information if we want to. So what happens in a competition robot is that you have the motors, and typically you have an encoder in the motors. And so the encoder allows you to determine how many times the wheel has rotated. So if you know the circumference of the wheel, you can determine, based on the number of rotations, how far the robot has moved. So we're going to now turn the robot. If you look over here, you have a variety of blocks, and there's the turn right block and the turn right for 90 degrees. And each of these are different. We're going to start with the turn right for 90 degrees. Now, the question, whenever you're turning with degrees, is what degrees are we talking about? Is it the robot turning itself, or is it the wheel turning? So 90 degrees on the wheel turn might not turn the robot around. So we're going to just test this. So now the robot turns and it works the way we want it. So that turns at 90 degrees. The first question is, if we're doing the basketball drill, we want our robot to move forward to this block, then turn around and move all the way back. So how many degrees will that require? We're just going to modify this. So if we switch that to 180 degrees and play, there we go. So our robot's turned around. You'll notice that I'm always hitting the restart button, and that's an important thing to do so that you're not running the program and then running it from here, which is going to give you a very different result because of where the robot is positioned. Now, a couple things with programming. You'll notice that I'm only dealing with one block at a time, and I'm testing what happens when I add that block. This is a really good strategy when you're programming. If you make a mistake, you know that it's only the last thing that you've done. So it's a very good strategy. So we need to now get our robot to go forward, turn all the way around, come back, and be ready to go to the next line. So we simply need to add another drive forward, and we will turn, but this time we're going to turn left 180 degrees. So if we play this, our robot turns, goes forward, and turns back the way we want it. Now, we would get the same result if we turned right, but obviously the robot would turn the other direction. So time to start thinking about the basketball drills. So our goal is to go forward, come back, and then go to the next block and come back. And we're going to repeat this pattern for 8 times. So with programming, you want to take big problems and chunk them and make them into smaller problems. So we've already got code that will work to be able to go forward and come back. So we're going to use that, and we're going to try to figure out how we can take that information and modify it. So we want to think about what we're doing. So we're going forward, going back, going forward 2 squares, going back 2 squares. So that is our requirements. There's a lot of different ways to program this, but as long as it meets those requirements, then we can do this. So let's just focus on 2 squares right now. Now, the nice thing is I can right click and duplicate, and that will duplicate all of those blocks. So right here, this is my first step where I go from the first one to the next one. And then down here, this is where I go 2 blocks. So instead of 200 millimeters, I want to go twice as far. So 200 times 2 is 400. So I'm going to try that, and I'm just going to run this. So I've gone 1 block, and now I've gone 2 blocks. So this worked. This is great. So I've got the pattern. Now, this is really important. With programming, there's a variety of ways you can do this. You could write this program and just simply keep adding 4 more blocks to be able to add that pattern, and you would get a fairly long program. So you want to go 1, 2, 3, 4, 5, 6, 7, 8 squares. So it would be 8 times 4 blocks of code. And that gets pretty big. So we're going to find a different strategy so that we can repeat this. So we want to think about what is our pattern. And I'm just going to switch back to our slideshow here. Here's our pattern. We want to go 200, and then we want to go 400, which is 2 squares, and then we want to go 600, which is 3 squares, 800, 1,000, and this is a pattern. And in math, we can look at the pattern and we can figure out what kind of pattern is it. Is it a linear pattern? Is it an exponential? And there's a lot of ways to do this. But the key thing is that we want to take our pattern and use the code. So the computer's really good at repeating patterns. And so we're going to take advantage of that. So with our code, we have a variety of different types of buttons, and one of them are control buttons. So if we add a control button, and I'm just going to undo what I just did. So let's just move this out of the way, bring that down, and there's our repeat. So the first thing is that I know I want to repeat this. I want to repeat it 8 times. So I'm going to repeat this 8 times. And I'm going to start by just dragging this in. And I'm going to drag those off the screen to get rid of them. So let's see what happens. This isn't going to work that's not my end result. What I want to see is, do I have the pattern? And yep, that seems to be repeating. So it's repeating 8 times. And I'm just going to pause it there. So this is working, but it's only one stage of my problem. So I know that I can now get this going back and forth 8 times. The next thing that I need to do is be able to have it go forward 1 block, then back, forward 2 blocks and back, and continue that. So that's my next stage for this. So what's going to change? So the first time through, I'm going to have repeat. So I'm going to go forward 200 millimeters, turn back, or forward 200 millimeters and turn. The second time, I want this to now be 400 millimeters. So that's going to go up by 200 millimeters. And if I look at this, here's the difference. I need a variable. So I need a variable that starts at 200 and then goes up by 200. So let's work on adding a variable. And when you have a variable, you can see there's this orange block of variables, and I can create a variable. So I'm going to make a variable and I'm going to call it distance. So variables are things that can change in your program, and you can make your own variables. And by creating them, if you give them a name that makes sense, it makes it really easy. So I'm going to start off right at the beginning of my program, and I'm going to set my distance to 200. So what's going to happen here is I want to replace this. So I'm going to drive forward my distance, which is 200. Now, if I run this, I'm going to get the same result that was happening before. My variable is not changing at all, so it's going to continue only going 200. So I need to now change that. So I'm going to change my distance by 200. So let's look at how this program is started. When it started, I set my distance to 200, and then I'm repeating this group of blocks 8 times. Drive forward my distance, which is 200, turn right, drive forward my distance, which is 200, turn left, and then I'm going to change my distance by 200. So now it should be 400. I'm going to drive forward 400, turn right, drive forward 400, turn left, then I'm going to change my distance again. So let's run this. Let's see what happens. So there's the first time through the loop. And now I have got my basketball program working the way I want it. So this is excellent. I've been able to get this working just the way I need it to. And when this is done, what I want to do is I want to make sure that my project is stopped when I am done. So I'm just going to add that block to the end so that when I've gone all 8 blocks, it should stop the program. So I'm doing the testing right now. As it's testing, I do want to highlight some things. Number one, you can change your velocity, so you can make this move faster. In the real world, you want to be very careful, because if your robot's too fast, obviously it could be dangerous. But secondly, there's more chance that the wheels will slip, so it won't necessarily be as accurate. So it's one of those things you have to be careful. The other thing is you'll notice that's a percentage. And I'm always amazed by the number of students that change the percentage to 1000%. The motors can only go up to 100%. So don't bother putting a number like 1000 in there. So we have our program, and everything seems to be working. Now we add a comment in here, and the purpose of the comments is to make sure that you document your work. So we call it basketball drills, and then you put your name. And comments are really important so that when you're handing work in, the teacher knows who handed it in and they know what the assignment is. So you always make sure you add a comment. And if you have something that's confusing in your code, you want to put a comment in so that way, if you come back to this later on, you can easily understand it. The other thing is that you do file save to your device, and that will now save the file to your program. If you're on a Chromebook, it will be in your on the device, and if it's on a Windows machine, it will be in the downloads folder. So we have completed this. Now it's time for you to do a bit of a challenge here. And just going to switch. So there's 3 possibilities here. Work with a partner, try to solve at least one of these challenges, but you can obviously do more. So basketball drills, same thing, but this time start by going 8 squares and then go 7 squares and then 6 squares. You already know how to create this program to do the standard basketball drills. How would you modify it to go those different amounts? The other way is go 1 square, then 2 squares, then 4 squares, and then finally 8 squares. So we're no longer using a linear equation. And then using a loop to make the robot move a square by moving from the bottom to the top, then to the right, and then down. So those are the 3 challenges, and they're tricky. They're meant to be tricky, but that's why you work in a partner and break the problem down into smaller steps. So that is the thing. You'll notice that there are a whole bunch of different types of buttons. So when you're looking at the blocks, take time to figure out what the different blocks are and what are operations. So instead of changing it by a certain amount, you could put in some math and you can work these things out. Those of you that have some interest in learning some more advanced programming, this button over here will show you this is the code in Python. So the Python programming language is one of the most popular programming languages out there. And you can see all the different code that they have for here. And you can make changes right in this code to be able to make this go differently. So I'm just going to, I'm going to convert it to a text project. And now I can actually program in Python. And it's good to just start with something small. So I'm just going to change that to 90 degrees and see what happens. And you can see now I'm getting a slightly different approach and my robot's ending up running into a wall. So that's not going to work for me. The other thing that I want you to be aware of is that you can take programming courses in high school at Huntsville High School. These are the courses that do programming. ICS is computer programming. TEJ, this is computer engineering, and then TER is robotics engineering. And each of the high schools have similar types of courses. You need to check with your guidance counselors about what courses are available. Hope you enjoyed the basketball drills lesson. Have fun and feel free to reach out to me via email if you're struggling with any of the programming.